Alright, welcome back. So now we're going to be looking at another lesson on factoring, and we're going to use one of the techniques that we use ultimately for expanding to do the reverse. So originally, when we had a original idea like a plus b multiplied by a minus b, the result would be a squared minus b squared. Okay, so when we're factoring, when we were expanding, this was our end result. When we're factoring, we want to go back to this result. So if we see any situation like where we've got two numbers that are clearly have a even or have a whole number square root, we can use this technique to quickly factor them. So if I consider this guy to be A and this guy to be B, then our end result should be x plus 7 times x minus 7. Okay, because 7 times 7 is 41. So we're 49. So we're looking for two exact numbers that have clearly been squared, and this negative symbol or negative or subtraction operator in between them. And this can be a really quick way to split up this entire expression into something that we might be able to cancel or use in different operations. So right now we can also check to see if this in fact does equal this. So if I do x plus 7 multiplied by x minus 7, we can either do our FOIL method, which is where we multiply each term by both of the other terms, right? Or we can split it up. Now let's just do the first way. So we do x times x, which will equal x squared, and x times negative 7 equals negative 7x, and then 7 times x is plus 7x, and then 7 times minus 7 is minus 49. And so because this is plus 7x and minus 7x, they both cancel out and become 0, and we're left with x squared minus 49. So it does work. This is our factored form. This is a really useful result, because lots of what we see in exercises involving factoring or involving algebraic fractions or complicated algebraic equations are made a lot easier when we factor out expressions like this one. Let's do another one. So we have 9x squared minus 16. Okay, so if we looked at this and we thought, well, this will be A and this will be B, we can clearly come up with two values here that when squared is going to be 16 and when squared is going to be 9x squared. Okay, first up for A, what number squared becomes 9? Well, it's 3. And then what pronumeral squared becomes x squared? X does. So we're left with our first one of A equaling 3x. What squared becomes 16? Well, 4. 4 becomes 16. So we know A is going to be 3x. We know B is going to be equal to 4. That means we can factor this because it's difference of squares and write 3x plus 4 times 3x minus 4. Really easy. We've automatically done it. The only issue here, and the one that you can make a mistake on, is either by not knowing the square root of something, in which case use your calculator, or making a mistake by not including the correct pronumeral. Alright, next one. We have 25a squared minus 49b squared. Okay, so when we want to look at this one, we're just going to consider, okay, what's the square root that we're going to be looking at here that's numerical? So what number squared produces 25? Well, it's going to be 5. What number squared when it produces 49? Well, it's going to be 7. A when squared produces a squared. B when squared produces b squared. So we've already solved what our two different terms are going to be. So all that's left to do is rewrite it as 5a plus 7b multiplied by 5a minus 7b. Okay, and you can see how once you start to recognize the patterns, this gets quicker and quicker. All right, we're going to factor 1 minus 49k squared. We can see that we have two terms here that in fact we could take the square root of both sides. So the first one, what would our a be? Well, it would be 1. 1 squared is 1. And what about this one? Let's start off with our numerical value. What squared produces 49? 7 does. And what squared produces k squared? K does. So we're left with 1 plus 7k times 1 minus 7k will leave us with exactly the same result. This is this, but in its factored form. All right, here's our last one. We have 3x squared minus 27. Okay, this is a little bit different. And the reason why it's a bit different is because we don't have a clear term that we are going to be able to take the square root of. We can't do the square root of 3 and won't be able to do the square root of 27. But what we can do is first apply our highest common factor way of factoring and then see what we have left over. So we have 3 and we have 27. Right, obviously 1 and 3 are going to be our factors of 3, and 1 and 27, all we have are 3 times 9 is going to be our factors of 27. So there we go, our highest common factor between these two is 3. You should be able to work that out in your head, but it's totally fine to do the entire list if you feel like it. So our highest common factor between these two terms is 3. That means I can divide both terms by 3. Okay, let's make some space. So this would be equal to 3 times, well, 3x divided by 3x squared divided by 3 will just be x squared, minus 27 divided by 3, which is 9. So just here you can see that this has difference of squares written all over. X, the square root of x squared is going to be x, the square root of 9 is going to be 3. So we can rewrite this whole thing as keeping the 3 out the front as x minus 3, x plus 3. So a lot of these questions, when they don't immediately give you the answer or an obvious set of powers in each term to take the square root of, they might want you to factor out something first. All right, that's it for this video. Hope it was helpful, and I will see you in the next one.